Characterize the temperature sensor, and that sensor is thermocouple.
In this experiment, you will find aim, theory, procedure, simulator, review questions, references, feedback, photo gallery, and people who have developed this lab.
Now, to simulate this, click on to the simulator and then start performing the experiment.
Now, in this case, a thermocouple is dipped in a vessel containing some liquid. A student needs to select which type of thermocouple he wants to characterize, like J, K, R, S, T. These are the 5 thermocouples
which we have tested. For example, I select J type thermocouple, which is of the type iron and constant, and the reference temperature is, if you compare it with the thermocouple chart,
reference temperature is always with 0 degrees Celsius. But if you compare the actual thermocouple with the cold junction, it will never be at 0 degrees Celsius. It will be at room temperature. So that you need to have cold junction compensation.
But for the purpose of performing the experiment, let me select reference temperature at 0 degrees Celsius, means whatever millivolts are generated, these are related directly to hot junction of thermocouple. Now, I'll select the temperature. The temperature selected is 268 degrees Celsius. Now, what you can do is you can refer to the chart and find out what will be the thermocouple output by clicking on to this thermocouple reference table. Now, this reference table will give you the thermocouple charts related to J type, K type.
So select J type thermocouple, which will give you the details of millivolts at a particular temperature. Now, please do not forget that the reference junction is at 0 degrees Celsius.
So refer to this chart and get the value. Enter this value. If your answer is correct, he will show you correct, otherwise recalculate. In this case, it is 14.56. I submit, it will show me it's a correct temperature. I'll have to take 3 readings.
The moment I submit, you will see that the level 2 is on, plot is on.
So if I click on to plot, I'll get this characteristic. As this is an ideal characteristic, it is showing a very linear characteristic.
But in reality, thermocouple will never have such a linear characteristic.
Then you can click on to level 2, in which you have already selected J type thermocouple. So J type thermocouple bare element will give you a time constant of 8 seconds.
How to calculate the time constant? So click on the formula. The formula is given, all the details are also given. Fill those details and solve these equations. Then you will get the time constant.
Then if you put a sheet and if you select material, for example SS316, and the thickness is 1 millimeter, time constant has become 10.95 seconds. So if I add a thermo well on top of that with the material SS316 and thickness suppose 2 millimeter and the filling powder is MgO, the time constant would be 16.79 seconds.
Now this clearly indicates that as you add thermowell or sheath, the response of thermocouple degrades.
So if you plot this graph, you will find that this is the step change. This is how your thermocouple has responded if it is only with bare element, this is with sheath, and this is with thermowell.
Now you can compare the time constant of thermocouple and RTD and suggest which is the best temperature sensor if you want good dynamic characteristics. Means you want better time constant.